Hey everybody, this is Mr. Palacios here, and we are going to learn about perfect squares in our quadratic equations and figuring out how to solve them when A is a perfect square. This is going to take a while. I hope to get it under 10 minutes though. We got 4 pages, so pay attention, take notes if you need to. We're going to start right here. If A is in function of x equals ax squared plus bx plus c, if A is a perfect square, then you set ax squared plus bx plus c equal to mx plus n squared. And we do that because we're going to factor everything out and find the square root of a and use that to solve the equation. Now, when we multiply that out, we get m squared x squared times x squared plus 2 times n, m times n times x plus n squared. B, because ax squared plus bx plus c equals m squared times x squared plus 2 times m times n times x plus n squared. M is equal to the square root of a, n is equal to b over 2 times m, which is equal to b over 2 times the square root of a. And our c, our n squared is basically c, and because n squared is equal to this squared, basically we're getting the square root of this, b divided by 2 times a squared equals b squared over 4a, or divided by 4a, plus all the negative counterparts of that. So you'd have plus or minus square root of a, plus or minus b divided by 2 times the square root, or sorry, b divided by 2 times the square root of a, and then negative b squared divided by 4a. Okay, so here's an example, and this is our a, b, and our c values. So for x squared plus 8x equals 21, we're going to add this number, which is, if you were paying attention, is our n value, or our c, the square root of our c value, or the square root of our n, which is our c value. So we're going to add that to both sides, and we can do that because anything that we add to one side, as long as we add it to the other, our equation stays the same. So we have b squared divided by 4a equals, if we go back to our equation, b is 8, 8 squared divided by 4 times a, 4, and that comes out to 64 divided by 16, which is 4. So we get 4x squared plus 8x plus 4 equals 21 plus 4. So we are going to factor the left side of the equation as a perfect square trinomial. In order to do that, we find the square root of this one, which is 2, and we get 2x plus 2. If we factor that out, if we were to work this out, it would come out to this equation. 2x squared plus 2 2 times x plus 2 squared equals 25. That's 21 plus 5. Now we apply the definition of square root, so we're going to square root this side and square root this side. And what we get is that 2 times x plus 2 equals plus or minus 5. And that means that there are 2 options available to us for x, 2 values of x. If 5 is positive, we have 2x plus 2 equals 5. Subtract 2 from both sides, you get 2x equals 3. Divide by 2 on both sides, and you get x is equal to 1.5, or 3 over 2. Okay. On this one, for the negative, you have 2x plus 2 equals negative 5. Subtract 2 from both sides, you get 2 times x equals negative 7. Divide by 2, and you get x is equal to negative 3.5. Okay, now, what happens if a is not a perfect square? Well, we're going to do something very similar, but first we're going to start off by multiplying both sides by a number that would make our a perfect square. So in this case, we have 2. 2 is not a perfect square, but if we multiply this by 2, then it will be 4. So we do 2 times 2x squared plus 6x equals 5. We multiply this side as well by 2, and we get 4x squared plus 16x equals 10. That's what happens when you just multiply it out, distribution. 4x squared plus 12x plus 9 equals 10 plus 9. So we're adding the b squared divided by 4a to both sides of the equation, just like we did on the previous one. Remember, we added this to both sides. And when we do that, we get 2. We can factor this out. 2x squared, 2x plus 3 squared equals 19. So we need to find that, make that apply the definition of square root, put our square root here, square root there, and we get 2x times 3 equals plus or minus 19. Those are our two options here. And so when it's positive, we have 2x plus 3 equals square root of 19. Subtract 3 from both sides. You get 2x equals the square root of 19 minus 3. Divide both sides by 2, and you get x equals the square root of 19 minus 3 divided by 2. Conversely, when it's negative, you get 2x plus 3 equals negative square root of 19. Subtract 3 from both sides, so you get 2x equals negative square root of 19 minus 3. Divide both sides by 2, and x comes out to the negative square root of 19 minus 3 divided by 2. Pretty easy so far. Now, the next thing we're going to look at is when a projectile is thrown, we're going to look for the arc. So you can use the quadratic equation to measure the arc of an object as it's thrown, as it's released, as it flies up in the air and comes back down. And this can be for any sort of object. It could be a rocket, it could be a ball, I mean anything basically. So the example I'm going to use is that I toss a ball off the edge of a 48-foot cliff. Okay, I normally wouldn't do this, but today I was feeling adventurous. The initial velocity is 8 feet per second, and so we want to graph the function. And in order to graph the function, we need to know this equation right here. And there's a couple terms that we're getting a couple new variables, so we need to know what they mean. So our equation is so the function of height to time. So how high it is per how long it's been in the air is equal to negative 16 times t squared, t is time, plus v times t, and v is the initial velocity per second, and then h0 over here would be the initial height, okay, h at 0. So the first thing that we need to do in order to graph this equation is identify v and h for the projectile motion function, and in this case we have the initial velocity of 8 feet per second, so 8 feet per second, and the initial height of 48. So we need to know what those are in order to plug those in and find our answers. So we're going to write an equation for the projectile motion function, and that is the function of h to t is negative 19 times t squared plus 8 times t plus 48. And then we're going to complete the square to find the vertex of the graph. And so we're going to start off with remembering that in order to find our vertex, we need to find our x and y values. Well, the x value can be found if we take negative, the opposite of b divided by 2 times a. So in this case, our b value is 8. So negative 8 divided by 2 times negative 16, 2 times our a value, negative 16. And what we do is we get negative 8 over negative 32 when we do that, and that is equal to 1/4 or 0.25. You can use either one of these numbers. And we're going to plug a and b into the equation to find x here. So that's what we did in order to find that x. Okay, and then our next step is to plug x into the equation to find y. So we have y equals negative 16 times 0.25 squared plus 8 times 0.25 plus 48. That gives us y equals negative 16 times 0.0625 plus 8 times 0.25 plus 48. That gives us negative 1 plus 2 plus 48. And so y is equal to 49. We found our x value, 0.25 or 1/4, and we found our y value, 49. That is the vertex of our function. That is a vertex of the graph. And so we would plug in this value into our graph in order to find where the ball is at its height. Everything else is going to be going down from there. Okay, and so we write the coordinates 1/4, 49. Now don't throw away those numbers because we're going to need them in order to find another value of x and y on the graph in order for us to graph this function. And so let's set the height as 0. So the function of h to t is 0. When we do that, we have negative 16 times t minus 1/4. This is where we're plugging in our values. 1/4 squared plus 49. That's our y value. So our x value and our y value equals 0. So we're going to subtract 49 from both sides. So notice we plugged in our x here and our y here. We're going to subtract the y and get that y over here. And we have negative 16 times t minus 1/2 squared equals negative 49. We're going to divide 16 from both sides. And again, we're looking for another point on our graph. So we're going to take the square root of, we have t minus 1/4 squared equals 49 divided by negative 49 divided by 16. Well, we're going to apply that square root, that definition of square root. We're going to take the square root of this and the square root of that. And so t minus 1/4 equals plus or minus 7 divided by 4. Notice 49, the square root of 49 is 7. The square root of 16 is 4. So we have t minus 1/4 equals plus or minus 7 over 4. We add 1/4, 1/4 to both sides. And so we have two possible outcomes, right? Because we have a plus 7/4 and then a negative 7/4. Well, t equals 1/4 plus 7/4, and that's going to equal 8/4 or 2. That's going to be one of our x values right here. Our other x value will be t equals 1/4 minus 7/4, and that's going to equal negative 6/4, and that's going to equal negative 3 over 2, or 1/2, 1 and 1/2. So t equals negative 3 over 2. And we can basically discard negative 3 over 2 because when we're looking at our graph, we want to know when the ball is in the air. Well, when our x value is negative, that represents a negative time. So we can't really graph that because we don't really care about the negative time because we didn't really throw the ball yet. So I mean, ideally it would come down here, but we really can just discount it. What we're really paying attention to is the arc of the graph as it is in quadrant 1. Anything that goes outside of quadrant 1 into quadrant 2 we don't need, and anything that goes into quadrant 4 we don't need as well, because 0 on the y-axis is essentially the ground, 0, so the ball's no longer in the air. But we have a point of 2, 0, and we know that the ball lands at 2, 0. So we plot our vertex, which is 1/4 49. As you can tell, it's about halfway in that. This is the half mark, that's 1, so it's about halfway in that, between the 0 and the half mark. And it's about 49. It's as close as I can make it, going up by 10, 10, 20, 30, 40, 50. And then down here we have 2, 0. So we went over 2 and then up 0, and that gave us our graph. So that covered a lot. Sorry that took so long. But use that information to answer the questions on the set that I'm going to have you guys answer today. Good luck. Take notes, review this if you need to. This was a lot of information.